The same is written here, the two types of triggering activation. One is pulse triggered, the other is edge triggered. Now the pulse triggered are latches, on and off. On is 1 and off is 1. And edge triggered are flip flops. As discussed previously, edge triggered can be either positive edge triggered or on. That is when the clock pulses move from 0 to 1, we say it is a positive edge trigger. Similarly, when clock pulses changes from 1 to 0, we say it is a negative edge triggered flip flop. Now let's start with SR latch. Latch, what exactly is the latch? Why we use it? Latch is actually a 1-bit memory element, or we can also say that latch are those circuits which does not store any value. Okay, latches, they can be said as latches are 1-bit memory elements. 1-bit memory element. Latches can be made of NAND gates as well as NOR gates. So the latches are made of NAND gates and also NOR gates. So to complementary output for latches are Q and Q bar. We'll definitely study the working of latches. Now let's go on. Before going on to the latches, let's have some theoretical value and then we'll explain how the latches work. The latches have two inputs and the outputs complementary to each other, that is Q and Q bar. When Q is high, the latch is set state, that is Q is 1, the latch is set. When Q is 0, the latch is in reset state, that is Q is equal to 0, the latch is in reset state. For active high input SR latch, also known as NOR gate latch, R is equal to high and S is equal to low. Therefore reset latch, S is equal to high and R equal to low, set state, both inputs low, no change, both inputs high, Q and Q bar, therefore it becomes invalid. Similarly, for active low input S bar R bar latch, also known as NAND gate latch, R bar is equal to low and S bar equal to high, it is called as a reset latch. S bar is equal to low and R bar is equal to high, it is called as set latch. Both inputs high, called as no change, both inputs low, Q and Q bar, both high, they are called invalids. So that is, let's study how the latches work. Let's study the working of NOR latches. First is NOR latch. The circuit diagram for the NOR latch can be as follows. Let us assume this is S, this is R. The NOR latch will be SR NOR latch. The circuit structure will be this, and circuit structure here will be this. Let us assume S is equal to 0 and R equal to 0. Okay, this is Q. This will be, let us assume this is Q bar and this is Q. So let's take initial state for the output. Q will be 0, therefore Q bar will be 1, as both the outputs are complementary to each other. These are the initial states where Q, the initial output is 0 and the complementary is 0. Now, how the NOR latch will start working? Which latch should be given the preference? So let's rename this as latch number NOR gate number 1, NOR gate number 2. Okay. Now in NOR gate, since this has both the input 0 0, therefore the preference or the activation of the gate will be that NOR gate which has at least one input. So from this gate number 1 and 2, we can see that this one goes here. Okay, this one goes as input to this one. Therefore gate number 2, NOR gate number 2 will respond fast. That is, one input R is equal to 0 and the other input is 1. So the output of the NOR gate will be 0 plus 1, which will be 0, and this 0 will go again here, and 0 into 0, which will be again 1. Similarly, therefore when S equal to 0, R is equal to 0, output Y is equal to 0, also called as hold state or previous output state. Similarly, let us now take example where S equal to 1, R is equal to 0, this Q initial output be 0 and Q bar is equal to 1. This is NOR latch number 1, this is NOR latch number 2. That is, in this case, S is equal to 1 and R is equal to 0. Since this NOR gate number 1 is having first input as 1, the gate number 1 will respond first. Therefore, this output here goes to the gate number 1. So 1 plus 0, that is, for the NOR gate the output is 1 plus 0, it gives 0, and this output 0 goes here, 0 into 0, 1. That is, when S is equal to 1, R is equal to 0, Y is equal to 1, which is called as set state. Similarly, when S is equal to 0 and S equal to 0 and R is equal to 1, we get output Y is equal to 0, which is reset state. Now, when S is equal to 1 and R is equal to 1, this state in SR latch is not permitted and we get it as invalid state. Therefore, the truth table for SR can be obtained as SR 0 0 0 1 1 0 1 1. Output Y will be 0 into 0, it gives 0 or the previous value of memory called as hold state. 0 plus 1, it gives 0 called as reset state. S is 1, 1 0, it gives 1 which is called as set, and 1 1 is invalid. Similarly, let's study the working of NOR latch. Let's study SR NAND latch. Let's say S, let's say R. Let S equal to 0, R equal to 0. Let us assume this is Q, which is initially 0, or the initial output. Therefore, its complementary output Q bar will be 1. Okay. So, let us see. Now, since this is a latch, NAND latch, we name this as 1, gate number 2. Now, in NAND latch, we have to check out S equal to 0 and R equal to 0. Since this both are 0, we have to give the preference. So, which gate needs to be preference, or which gate will respond first, whether it's gate number 1 or whether it's gate number 2. To solve this, the NAND gate having the input 0 will respond first. Now, here both the inputs are 0. But now let's see for gate number 2. Gate number 2 gets the input 0 from Q, and gate number 1 gets the input 1 from Q bar. So in this case, which is opposite to the NOR gate, NAND gate 2 will start working fast because it will have 0 0. So this 0 will flow here and we get the output 0 0, which is 1. The same output flows here, 0 1, it gives 1. So as we can see, when S equal to 0, R equal to 0, Q is equal to 1 and Q bar is equal to 1. But it is logically not possible for Q to be equal to its complement. That is, Q cannot be equal to Q bar logically. So in this case, when S equal to 0, R equal to 0, we consider Y as invalid state. Now let's take S equal to 1, R is equal to 1. Let's take Q equal to 0, Q bar is equal to 1. So as we see, gate number 2 will respond first because it will take this 0 here. So 1 into 0, the output gives 1, which again will flow here. 1 into 1, the output will be 0. That is, when S equal to 1, R equal to 1, in this case Y is equal to whole, or it gives the output which is having previous out. Therefore, the truth table for SR NAND latch is A B 0 0 0 1 1 0 1 1. 0 0 will be invalid, 0 1 will be 1, 1 0 will be 0 called as reset, this called as set, 1 1 will be hold. This is the working of SR NAND latch.